Today I am going to talk about two-tailed test and single-tailed test. When we use two-tailed test and when we use single-tailed test, this is going to be the point of discussion of today's class. So, the null hypothesis is always of no difference. It means that whatever is the claim, null hypothesis normally supports the claim. Suppose a person has claimed that the mean life of the bulb is 6 months and we want to test this claim by taking a sample of bulbs. So our null hypothesis will be that the population mean is equal to 6 months. So null hypothesis, which is represented by H0, is always mu is equal to mu0, where mu is the population mean and mu0 is the claimed value of the mean in that particular question. Alternate hypothesis can have symbols not equal to, greater than, or less than. Okay. Suppose you have administered a particular type of fertilizer on a particular crop, and now you want to say that the production is more than average. Because of this fertilizer, the production has increased. So the alternate hypothesis will be mu is greater than mu0. Suppose we are claiming that after giving a particular drug, the number of people getting the disease are less than the previous when the particular drug was not given. In that case, the alternate hypothesis will be mu is less than mu0. So when the alternate hypothesis has greater than or less than symbol, we apply single-tailed test. And if the alternate hypothesis has not equal to symbol, two-tailed test is applied. When a particular person is claiming that the average life of the bulbs manufactured by it is 6 months, so our null hypothesis is that population mean is equal to 6 months, and the alternate hypothesis is that the population mean is not equal to 6 months. In this case, we will apply the two-tailed test. So, this diagram in this slide shows T distribution plot for two-tail with alpha is equal to 0.05, where alpha represents the level of significance and df is equal to 20. df represents the degrees of freedom. As shown in the figure, the rejection area is lying on the both sides of the graph. We are saying that the population mean is equal to 6 months, and the alternate hypothesis is that it is not equal to 6 months. So the rejection region is on both sides of the curve. If the alternate hypothesis contains greater than or less than symbol, the rejection area is only on one side of the curve. But here, when the symbol is of not equal to, then the rejection area is on the both sides of the curve as shown in the diagram with the which is the particular region which is colored, that is rejection area. अगर आपके सैंपल की वैल्यू बीच वाले एरिया में फॉल करेगी तो आप एक्सेप्ट कर लेंगे नल हाइपोथेसिस कि जो सैंपल का मीन है वो पॉपुलेशन के मीन के बराबर है. लेकिन अगर आपकी जो सैंपल मीन की जो वैल्यू है वो रिजेक्शन एरिया में फॉल करेगी, जो कि शेडेड एरिया दिख रहा है हमको अपने फिगर में, तो हम उसको रिजेक्ट कर देंगे. तो टू टेल टेस्ट में रिजेक्शन एरिया दोनों साइड होता है कर्व के, जबकि सिंगल टेल टेस्ट में क्योंकि उसमें ग्रेटर देन या लेस देन का सिंबल होता है तो वो रिजेक्शन एरिया सिर्फ एक ही साइड होता है. In case of single tailed test, the rejection area is on one side of the graph. Here in this case, the lower values are acceptable, but the higher values are not acceptable. So, the rejection area is on one side of the graph. Graph shows that the shaded area is on the left side. So the rejection area is on the left side, and when the value claimed value is less than the population mean. So this is the case of single tail test where alternate hypothesis has less than symbol. For this example, here we want to consider a new parts supplier. This supplier is claiming that the strength of the parts supplied by this supplier is 102. The current supplier is supplying parts with strength 100. So this particular new supplier who is claiming that the parts supplied by him have a strength of 102. So we want to check the claim. So what we will do in this case, the null hypothesis is that the mean strength of the parts is 100 is equal to 100, and the alternate hypothesis is that the mean strength of the parts supplied by the new supplier H1 is mu is greater than 100. तो हमारी H0 क्या है, म्यू इज इक्वल टू 100, एंड H1 क्या है, म्यू इज ग्रेटर देन 100. जो नया सप्लायर है उसके जो पार्ट्स सप्लाई कर रहा है वो उसकी स्ट्रेंथ वो क्लेम कर रहा है 102 है, हमारी टारगेट वैल्यू 100 है, तो वो क्लेम कर रहा है कि उसके जो सप्लाई वो कर रहा है वो उससे ज़्यादा है, 100 से ज़्यादा है. तो हमारी ऑल्टरनेट हाइपोथेसिस इस केस में क्या है कि जो म्यू है इज ग्रेटर देन 100. तो इसको हम इस हाइपोथेसिस को टेस्ट करेंगे, और अगर करेक्ट आती है, एक्सेप्ट हो जाती है, नल हाइपोथेसिस रिजेक्ट हो जाती है और अल्टरनेट हाइपोथेसिस एक्सेप्ट हो जाती है, तो हम इस पर्टिकुलर नए सप्लायर को सिलेक्ट कर लेंगे. और नहीं तो अगर हमारे जो मतलब अगर इसकी जो नल हाइपोथेसिस एक्सेप्ट हो जाती है और ऑल्टरनेट रिजेक्ट हो जाती है, तो इन दैट केस हम अपने पुराने सप्लायर से ही सप्लाई करवाते रहेंगे. कैन मेक अ मिस्टेक इन बोथ सिंगल टेल टेस्ट और टू टेल टेस्ट. We can accept a hypothesis which is actually incorrect, or we can reject a hypothesis which is actually true. So in both the cases we are committing a mistake. So there is a sample through which we are making a conclusion, and after applying the test we found we have accepted the null hypothesis, but in reality the null hypothesis is not true. Okay, we have accepted the null hypothesis, but in reality it is false. This is type 2 error, as you can see in the figure. And through our data we are rejecting the null hypothesis which is actually true. In real life this null hypothesis should have been accepted, but due to some error in our data we are rejecting the null hypothesis. Our conclusion is such that we are rejecting the null hypothesis. So if we are rejecting a null hypothesis which is actually true, then we are committing type 1 error. So these are the two errors that we may commit in statistical analysis. If a hypothesis, if we are accepting a null hypothesis which is actually true, then we are not committing any error. If we are rejecting a null hypothesis which is actually false, then again we are not committing an error. So in two cases we are committing an error. We are rejecting a null hypothesis which is actually true. This is type 1 error. We are accepting a null hypothesis which is actually false. We are committing type 2 error.